Well, hello there, and welcome back for more Advent of Code. So, we are on December 16th, but we are one day behind schedule and haven't done day 15 yet. And look at that. It seems like we're starting to go down in this map. I wonder if 14 was the highest point. It seems to be, because this is like 2 lines, while all the other ones are like 1 line. 15, 16, 17 will be here. 18, 19, 20, 21, 22, 23, 24, 25, maybe. So yeah, it seems like now we are going to start to go down, providing the different resources that each floating island was needing. Okay, let's see what day 15 is about. And before I forget, I should put a stopwatch. Let's go. Day 15, Lens Library. The newly focused parabolic reflector dish is sending all its collected light to a point on the side of yet another mountain, the largest mountain of Lava Island. As you approach the mountain, you find that the light is being collected by the wall of a large facility embedded in the mountainside. Cool. You find a door under a large sign that says Lava Production Facility, and next to a smaller sign that says Danger, personal protective equipment required beyond this point. I like how the name is very descriptive. A good reminder of using good variable names. As you step inside, you are immediately greeted by a somewhat panicked reindeer wearing goggles and a loose-fitting hard hat. So this is a Wikipedia article for hard hats, which, yeah, the sort of construction worker kind of hat. The reindeer leads you to a shelf of goggles and hard hats. You quickly find some that fits, and then further into the facility. At one point, you pass a button with a faint snout mark and the label "Push for Help." No wonder you were loaded into that trebuchet so quickly. So yeah, this is a reference to the first day. So I guess the reindeer was pushing buttons for asking for help, and that prompted the elves to launch us on the trebuchets at the beginning. I actually don't remember what was the the reason, the initial problem that we were having. Oh, something is wrong with the global snow production, and you have been selected to take a look. Okay, so so you start with a problem in the snow production, but we went up all the chain of dependencies. Cool. You pass through a final set of doors surrounded with even more warning signs and into what must be the room that collects all the light from the outside. As you admire the large assortment of lenses available to further focus the light, the reindeer brings you a book titled Initialization Manual. Hello, the book cheerfully begins, apparently unaware of the concerned reindeer reading over your shoulder. Wow, the reindeers here are very intelligent, it seems. Well, maybe the reindeers in our world are intelligent too. We just don't know. Maybe we are the idiots all along. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Awesome. First, before you begin, please be prepared to use the Holiday ASCII String Helper algorithm, Appendix 1A. You turn to Appendix 1A, and the reindeer leans closer with interest. The reindeer is interested in ASCII. Cool. The hash algorithm is a way to turn any string and this is a Wikipedia link for strings of computer science. I'm reading those down here. I always read where links are pointing before clicking them. Just a paranoid habit of mine. What did it say? The hash algorithm is a way to turn any string of characters into a single number in the range 0 to 255. To run the hash algorithm on a string, start with a current value of 0, then for each character in the string, starting from the beginning, determine the ASCII code for the current character in the string. So this is the ASCII table, so this might be useful or not. Yeah, determine the ASCII code for the current character on the string, increase the current value by the ASCII code you just determined, set the current value to itself multiplied by 17. Okay, so we're going to need to hold these numbers in something greater than a single byte. Set the current value to the remainder of dividing itself by 256. Okay. After following these steps for each character in the string in order, the current value is the output of the hash algorithm. Okay, so this is actually like a pretty standard hash algorithm, pretty simple one, like multiplying by a prime number and then taking the remainder of what you get. So find the result of running the hash algorithm on the string. To find the result of running the hash algorithm on the string hash, very meta. So the current value starts at 0, then the first character is age, which is 72 in ASCII. Okay, makes sense. So the result of running the hash algorithm on the string hash is 52. The initialization sequence, your puzzle input, is a comma-separated list of the steps to initialize to start the lava production facility. Ignore new line characters when parsing the initialization sequence. Interesting that it's talking about parsing stuff. To verify that your hash algorithm is working, the book offers the sum of the result of running the hash algorithm on each step in the initialization sequence. Okay, for example, this thing. So the initialization sequence is our puzzle input, so I guess this is an example of initialization sequence. The initialization sequence specifies 11 individual steps. The result of running the hash algorithm on each step is as follows. Okay. These things are suspiciously looking like assignments and something. QP minus, PC minus. PC minus is very suspicious. For PC is program counter, right? I think so. But a very common name, register name for instruction sets architectures. Okay, in this example, the sum of these results is 1320. Unfortunately, the reindeer has stolen the page containing the expected verification number and is currently running around the facility with it excitedly. Run the hash algorithm on each step in the initialization sequence. What is the sum of the results? The initialization sequence is one long line. Be careful when copy-pasting it. Okay. And the input is, wow, a giant line. Okay. It's interesting that they don't give you this thing separated by new lines, and instead it's being separated by commas. And I wonder if they do that to like obfuscate sort of what's happening here. But okay, part 1 seems relatively straightforward, I would say. So let's jump into the code. And let's start where we usually start, copying the template. And I'm going to close everything else. This is what was the lens library? What did this have to do with lenses? Where did we talk about lenses actually? Okay. So we are in a room full of lenses, but we are just reading about some initialization manual, and this the only the only mention of lenses is here. Okay, lens library then. This is day 15. Lens library. Cannot write. Also copy input folder. Directory, I should say, because this is Unix. And one thing about this, and it's mentioned in the description, is that, yeah, be careful when copy pasting. And here I'm pasting, and you can see that it pasted a second empty line. And if we remove that and save, editors very like normally insert a new line at the end of files if there's none, and I think I can do Control K, Control S. Now Control K S, or maybe that's it, but I remove that new line, Control K S. Yes, okay, that saves without formatting, but I'm probably going to forget about doing that, so let's leave the new line and parse it out when we remove it when we parse things. So this is an example of initialization sequence. It should go here, and the output for this was 1000 something. It's this. Okay, so this should be the output for part 1. All right, so we're gonna have the input. We're gonna, first of all, before we forget, let's strip trim end, yes. I'm pretty sure the trim ends does, yeah, it removes white space. That's cool. We're gonna get this, and we're gonna separate by commas, right? Let's just write this. Let's just write this as we want. So the what is the sum of these results? So yeah, this is just simply hash sum, or like verifications and number or something. Verification number. Okay, but yeah, we will get sum of hashes. So here we're going to map with a hash function and sum this thing up, and let's use I don't know, like the hash gives us I guess an 8-bit number, but well, we don't need to return just a byte. We can use a 64-bit number and just work with our architecture. But well, the hash function is going to take a string slice and return a number. Yeah, use 64, let's say. And this is the result of doing these. Now, ASCII codes are just also like the Unicode value of each character. So we could use bytes for this. Maybe it makes more sense to use bytes. well, let's do this thing internally. So we can say string as bytes, or we also have a bytes iterator, right? Yeah, let's use the bytes iterator, and let's just simply fold this thing starting with 0, and then this thing, the fold function, does it take accumulator first? Okay, so it takes the accumulator and the byte b, and we are going to do so the next value for the accumulator is going to be accumulator plus the value of the byte. This is a U8, so let's convert it to U64. And all of these mod 256. And that should be it, right? Is that it for part 1? Hash sum. If that's it for part 1, it was a very simple part 1. Let's close this and cargo run day 15 and passing the inputs 15 sample. No, I screwed something up. So let's actually print the hash of hash, which is another example 36. Is that correct? No. So I'm messing up the ASCII codes. Aren't the ASCII codes the same as X? Yeah. The first one here was capital H, so yeah, hash. Capital H here is 72. Is that? Yeah, this is decimal. Huh. Okay, let's let's not do this. Let's just print the hash of hash and add some printing because I don't know what's going on there. So what is the byte? Print line hashing byte b. Boom. Yeah, it is 72. Oh, I didn't multiply. I didn't multiply by 17. So what is it that I had to multiply by 17? The I guess the result of adding the accumulator, right? So where was the hashing? Yeah, we increase the current value by this, multiply by 17, and then mod. Okay. That was pretty dumb on my part. Sure. So is this correct now? 52. Okay. What a dummy. Is this now the correct answer? Yes, it is. And we're still printing this. Let's remove the printing and let's actually run with the inputs. And is this the correct answer for part 1? And it is. Okay, so incredibly simple, easy part 1, especially for day 15 already. So I'm dreading part 2, and oof, there's some light physics going on here, so part 2 might be quite more involved. You convince the reindeer to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe a series of 256 boxes numbered 0 through 255. Yeah, because things should be numbered this way. I have a friend that hates zero-based numbering and indexing, so he would hate this this puzzle. The boxes are arranged in a line starting from the point where light enters the facility. Okay, the boxes have holes that allow light to pass from one box to the next all the way down the line. Okay, so box 0, yeah, each box has holes and the light passes through. Cool. Inside each box, there are several lens slots that will keep a lens correctly positioned to focus light passing through the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. Okay. Along the wall running parallel to the boxes is a large library containing lenses organized by focal length, ranging from 1 through 9. The reindeer also brings you a small handheld label printer. What is a label printer? It's this thing that prints. It's not the same like as a tag printer, I think, but okay. The book goes on to explain how to perform each step in an initialization sequence, a process it calls the Holiday ASCII String Helper Manual Arrangement Procedure, or HashMap for short. Okay. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. The label of the lens on which the step operates. The result of running the hash algorithm on the label indicates the correct box for that step. Okay, so the label is a string and you run the hash to know which box. Okay, cool. The label will be immediately followed by a character that indicates the operation to perform, either an equal sign or a dash. That is what we saw. If the operation is a dash, go to the relevant box and remove the lens with the given label if it is present in the box. Then move any remaining lenses as far forward in the box as they can go without changing their order. Filling any space made by removing the indicated lens. If no lens in that box has the given label, nothing happens. Alright. If the operation character is an equal sign, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label marker to mark the lens with the label. Sorry, I'm getting confused with all of these instructions. It will be followed by a number indicating the focal length of the lens that needs to go in the relevant box. Okay, so the right-hand side of the equals is a number, and I think focal lengths were from like 0 to 9 or something like that. Needs to go in the relevant box. Be sure to use the label marker to mark the lens with the label given in the beginning of the step so you can find it later. You mark the lenses, okay. Okay. There are two possible situations. If there is already a lens in the box with the same label, replace the old lens with the new lens. Remove the old lens and put the new lens in its place. Now, not moving any other lenses in the box. Okay, so we are doing this hashing thing to identify the boxes, but each box could contain different lenses with different labels, so we have to keep the labels. We cannot just forget about the labels and transform all the initialization sequence to their hashes, because each box can contain multiple lenses. But we know that all the lenses in that box, I think, should have the same hash, because the hash corresponds to the box. If there is not already a lens, okay, so if there is already a lens with the same label, replace the old lens with a new lens, remove the old lens and put the new lens in its place, not moving any other lenses in the box. And the lenses are sorted in the box. Okay. Add the lens to the box immediately behind any lenses already in the box. Don't move any of the other lenses when you do this. If there aren't any lenses in the box, the new lens goes all the way to the front of the box. Okay, yeah, things are sorted there. Here is the contents of every box after each step in the initialization sequence above. After Rn1, box 0 has Rn1. So 1 was the focal length. Okay. So minus, what did minus do? And remove the lens with a given label if it is present in the box. Okay. So I guess this did nothing. Cm equal 2. Oh no, sorry. Then comes Qp equal 3. So in box 1 you have Qp3. Cm equals 2. You have another lens in box 0. Qp minus, you remove Qp. That's fine. PC equal 4. So yeah, this didn't have anything to do with program counter or anything. It's just labels of things, and it's not like you're interpreting. Well, you're interpreting something, but it's a weird machine. Okay, you're putting things, you're putting more things. That's fine. PC equals 6. This one is interesting. No, here PC goes away. Then PC equals 6. Okay. And yeah, when you remove something, you remove it from the beginning and shift everything else. Okay. All 256 boxes are always present. Only the boxes that contain any lenses are shown here. Within each box, lenses are listed from front to back. Each lens is shown as its label and focal length in square brackets. To confirm that all of the lenses are installed correctly, add up the focusing power of all of the lenses. The focusing power of a single lens is the result of multiplying together 1 plus the box number of the lens in question. Okay, the slot number of the lens within the box, 1 for the first, so it's all one based. The numbers of the boxes start at 0, but then you use 1 indexing. Okay, the focal length of the lens. All right, so you compute this focusing power. At the end of the above example, the focusing power of each lens is as follows. Yeah, okay. This will make sense. It is what we have to compute in the end, but first we have to make the algorithm to put things into boxes. So the above example ends up with a total focusing power of 145. With the help of an over-enthusiastic reindeer in a hard hat, follow the initialization sequence. What is the focusing power of the resulting lens configuration? Okay. Okay. Fine, so we have to interpret these things. Good. So, this is very much fun for part 1. Part 1 was, look at how short it was. I could have also inlined this here, but it's nice to have it as a very thing because we are going to use it again. But it was surprisingly easy. Now part 2 is going to be more involved, but also I don't think it's too bad. So what I'm wondering is, does it make sense to model these steps somehow, like have an enum of these two things, or do we go and do like parsing and interpreting at the same time? It's like I'm tempted to maybe do that, but no, let's actually parse this thing. So this thing separated by commas, fine. So let's see. It was a very long part 2 description, pretty long. So what we have is an initialization sequence, which it contains steps, I guess. It doesn't talk about instructions, right? Instructions, no. Step is the step. List of steps to start. Okay. So we're gonna have this for part 1. We don't have to parse the steps. We compute the hash for each. So this is fine for part 1. For part 2, let's actually trim the end in here, so that we have the thing. For part 2, let's have the initialization init sequence, which is going to just be a vector of steps. We're gonna do also input split by commas, and then map these things into parse step, let's say. And then this parse step might fail, so we're gonna have to try collect. Okay, if I can type, and this thing generate this thing. It's gonna be a result of step, and let's use our dynamic result. And what is a step? Well, a step can either be so the minus is basically like a remove from the box, right? Yes, minus is remove, so it's also nice to use an enum so we can have nice names. And I guess here I should use a string slice for this. I could use an owning string and not worry about lifetimes, but I don't want to copy things unnecessarily. Let's be nice Rust programmers. So one thing is remove, and the other one is like a put that will have a label and the number corresponding to the, how do you say this thing? The focus in like the length itself. Equal sign, it will be followed by the focal length. Yes, okay. These things could be structs also, right? So I can also do this and call it label, I think. I'm pretty sure that this was, yes, okay. Let's put names, why not? Label and focal length. Let's name things, why not? But these things need an associated lifetime, so I guess this thing has to be parameterized with lifetime. but I hope that this is the only lifetime annotation that this program needs, and everything else can be inferred. Hopefully. Yeah. So in order to parse a step, what do we do? Well, we're going to basically ask if the string ends with a minus sign or if it has an equals sign. And otherwise, it's an invalid step. So, if the string ends with a minus, then just return a step of remove, and the label shall be the string sliced from the beginning till length. Can we say yeah, length minus 1, I guess. Sure, right? Let's add a to do here so it doesn't complain. What do you care about this? Oh, it should be a result. So let's say okay. Okay, dude. And this is problem. And we have to. Sure, right? I don't think we have like the match statement. Can the match statement be used for this? And match single characters? I don't know if it can. So okay, let's leave it like that, and let's say if let label and focal length be I just thought about something there. Let's say if splitting the thing, string split once by an equal sign, if we can do this, then it's an assignment or a put. So return step, or I guess okay, step put with this label and the focal, I guess focal length, you can say let focal length equals focal length dot parse and propagate any error. Okay. I don't really like when Rust changes things to be multi-line like this, because it makes everything unnecessarily long, in my opinion, but meh. And otherwise, if this didn't work, we can just return an error case and say, well, we can format here, say invalid step, and just print the S. Okay, and these we probably need to, can we do it with this? Yeah, okay. So this is fine. I was thinking of, instead of saying ends with, we have a method called strip suffix, and this thing returns a string slice with the suffix removed. Yes, so you can say strip suffix and use the same idea as below. So if there is a suffix to strip, and this will give me the label directly, so here I don't have to do the stripping again. Okay, so this is nicer. Yeah. I sort of like this a bit better now. Okay, so oh, this is a dumb mistake here. So what should we do? The problem here is that the temporary value that is being returned by this thing is dropped after this statement or after this expression. And since this input is a slice, need to reference this same thing, it cannot be dropped, and Rust is telling us that we should give in this thing a binding, so with this the error goes away. But I like to call this thing input, so let's repeat the trim end here. No problem. That's I don't like multi-line things, but we can still maybe make it one line by doing this. Yeah, okay, that's awesome. So we have the initialization sequence, and I'm getting a bit warm here. Let me lower the temperature. We're having very warm days in Buenos Aires now, very humid days also, and so I'm running the AC with the dehumidifier thing on, but it's barely keeping up with this. Let me a second, I will close some doors. Okay, and I'm back now with the bathroom and some other things closed. Maybe the AC can keep up. Okay, where were we? We have parsed the initialization sequence. I guess we can maybe run this with the input, and well, there are some warnings, but it didn't fail, it didn't crash, so that's fine. The initialization sequence then, it's a vector of steps, but luckily the lifetime of these things didn't need to be specified, so that's good. Yeah, this is fine. Parsing. What do we need to do next? We have to basically run this initialization sequence and put things into boxes. So we could have a struct for a box or something, but a box is just a collection of lenses, and lenses are just numbers, so we can have the boxes just be a fixed size, like each box will be a vector basically, and we're gonna have 256 boxes, so we can just have, let's say, let boxes be a static array of empty vectors, and let's have 256 of these guys, right? Yeah, and they start as empty vectors. These things are going to be mutable because we need to do stuff to them. We have the initialization sequence, and actually we run the initialization sequence once, so yeah, let's do a good old for loop for each step in its sequence. We're gonna do something that modifies the boxes, and then we need to compute this, what is the focusing power of the resulting lens configuration? So focusing power of all the lenses. Yeah, we're going to run this, but we can do that with the boxes. We don't need anything else on the init sequence, so we can even not collect yeah, not collect the initialization sequence. If we do that, yeah, let's actually not do this like this. Let's just have here we map. We are splitting by this, map into a hash. Yeah, we can just iterate this and say let step be parse step and barely return here. And it's like I don't know if this is better or not, but let's do it. And this is complaining because what? Can't I do this? I just want to have empty vex, but you cannot be copied. Yeah, I know that you cannot be copied, but you don't have to allocate any memory. Well, I guess we can use a vector. Yeah, sure. So boxes. It's gonna need a type, but maybe it can be inferred when we start using them. So we're gonna have a step. Great. And we're gonna match this step, and we can you help me out when we do the match? Well, yes, we're gonna have either a put or a remove. What do we do in each case? Well, actually, in both of the cases, we're going to be accessing the box given the label, right? So there is some like repeated thing there, but well, here we are going to, when we remove, we're going to remove the lens that has, so okay, the boxes themselves, yeah, what is this going to be? A box should be, let me think. I'm also thinking about how to do this array initialization. I'm pretty sure that there is a way of doing this. You know what? Actually, if we mark this, it's going to be, no, not a vector. I want this to be a static array of 256 of vectors of what? Well, the boxes are going to have, they need a label and a, so yes, each lens will be a label, basically a vector of lenses. And maybe I can have a type alias for lens, so well, it's going to need another lifetime annotations for this, so let's just write it in line here. A lens will be a label and the focal power or focal something of that lens, focal length, yeah. And can we just say default this? Does this work? Not exactly, but default does work. Must be almost there. Not specified. Oh, so it's specified for little arrays. So damn it. This must be something very simple, but maybe it doesn't want to have like, yeah, it probably doesn't want to have a bigish static array here in the stack. So yeah, what am I optimizing here? Let's just use a vector of vectors as we had before. It's much simpler to think about. So yeah, empty vectors to start, so 256 of those. That's fine. To remove a given label, we are going to what? Get the box by the hash. So I'm gonna run the hash of this label, sure. And since we are going to be accessing boxes with this, maybe the hash should be a usize. And so here we just do this, and hash sum is this, and okay, now we can just access the boxes by this. Great. And this is an array, so sorry, a vector. So we want to do we have a remove? But yeah, this gets an index. Well, that's basically what we need to do, right? And there's a swap remove. What did swap remove did? This was an interesting one. Who's an element and returns it? The removed element is no, it's replaced by the last element in the vector. Yeah, this avoids shifting everything, but it's exactly what we don't want to do. So we want to remove the lens with this label, but we have to like find it. Isn't there like a retain or something like that? Retain, yeah, retains only the elements specified by the predicates. Yeah, this is what I want, right? It's kind of like finding the thing and then calling remove on that, but we can do it in just one go, I guess. And we don't need to do anything crazy here. So we're gonna retain, and these are pairs of label and a label L and a focal length that we are not going to use. And let's retain the things which label is different to the label of this instruction. And this here comes in explicit types are explicit. Yeah, this still doesn't want to infer what's in the box. What's in the box? But maybe it will when we implement put. So let's actually put before. And oof, this wants to destructure things like this. I don't really like that. I think I will change these things to be simple tuples. But let's first, okay, put is going to be pretty simple, right? We just need to put the thing on the box, but what happens when there was a collision? And I don't remember that. There is already a lens in the box with the same label. Replace the old lens. Okay, so if it is there, we replace it. And that is, yeah, that is an if condition, right? We cannot do this generically, I think. I think so. So if there is, we just replace the lens. Okay. Let's then just do something like just find, yeah, we can do if we can find this label in the box, so we can probably extract also. I want to have a reference to let mute box be, oh, box is reserved, it's a keyword of this language that I'm using. So the box this is gonna be the box, but I want to keep a reference, not just move it out. I think this is going to complain about the moved out value, but let's see about us dropping that thing. If there, yes, position, how do we get the position? So we can say the box. We don't have a position here, but we can iterate and get a position. A position, again, a label, and want to find the label. So this time we want it to be equal. There is some repetition between these two, so I'm wondering if this thing could be done in a different way. But anyway, yeah, it's like in both cases we are getting the box itself, but that's okay. If the thing is already in the box, we can say the box in this position, assign it to label and focal length. So we just override it. Right? That's one idea. And this is now complaining because label is this, label here is a double string thing. So we can borrow here, we can borrow here too, right? Yeah, these things are very trivially copyable, so why not? And now types can be inferred correctly, and we can say like not specify the type of the boxes, which of course makes the code like probably more difficult to read. It would be better to have the type of this here, but let's roll with this. And here I guess it is going to be complaining, yes, cannot move out of this. I want a reference to this thing. And you don't like these because cannot. So if we do this, the box. Oh, we want to have a mutable reference, I guess. Sure. And that is if it's in the box. What's in the box? And otherwise, we're gonna say the box push this thing, this same thing. So there is some little repetition here, but yeah. It's fine, right? It's fine. Couldn't we say I think this same thing could be also expressed as like using a mutable iterator and using find in this. So if we find the thing, what's your problem here? Cannot. Sorry. And I borrowing more than necessary. This is double. And now instead of position, it's going to be, yeah, we could do something like this. Find the lens and change the lens in here, like replace, say, hey, lens, assign the focal length. This is also, I think, yeah, it's this a way of doing the same thing, which, yeah, I guess it's fine. It's fine. So yeah, I'm wondering if inlining this would be better. So just not, well, I don't like the variable name, the box, but I'm already like backshading this. We can do that at code review time. Now it's implementation time. So this should be it for the initialization sequence running. And after this, if we have things, if we have done things correctly, we can compute, what was it? Focusing power. I have the focusing power. Okay, so let's say let's total focusing power is gonna be boxes, iterate over them, and for each box we are going to map the focusing power of each lens, right? But we need also the index of the box. So yeah, box 0, yeah, it's this, and then the slot. Okay, so we need to do that, and the focusing power is a 64-bit number. I think we can also use probably a U size there and not have to. Oh wait, no, let's use the zip trick. Here we can use do this and zip with 1 onwards, and then we will receive a box and a box index. Well, let's call it I. I guess box index. Let's give this thing a proper name because we're gonna be multiplying some things together. So each box is basically a collection of lenses. So, you know, if I didn't like this name, is because I can probably call this thing lenses. That's what's in the box, so we can do that. And then we are going to do what? Basically, for each box itself, lenses, we're gonna iterate, and we're gonna again zip with 1 onwards and gonna map each of these to something and some again. And what are we mapping these to? Well, now we are going to have a single lens and a lens slot number. Yes, so we want to have focal length. Okay, so the label we are going to ignore, in case label. Just call it L, which we are going to ignore. And then we have a focal length, which we are going to use. And we are going to map then the box index. This is wrong here because we are zipping, so this is the lens itself, and then we have the lens index. Okay, this is going to be box index. Is everything multiplied, right? times the lens index times the focal length. Look at that. Pretty ugly, but that's just because the Rust formatter likes to break things into lines very, very often. Type annotation is needed here. I'm never sure why some really need so many type annotations, like it really wants to. So yeah, but I think we're gonna need this, right? Because we are summing all of this. Sure. Focal length. Yeah, I think I want to have this nested like this. It's probably, this is one of those things that would probably be better written as like in 2 nested for loops. And you don't like this. Cannot be made by some iteration of, oh, U64. What is a U64? Oh, okay. Oh yeah, I was using the zip trip trick for that. Oh, so actually the result of this should be U64. If I put this, do you still need? It seems like it still needs that. So, okay. And we're gonna finally print the total focusing power. If we run this with a sample, we get something that looks very wrong, but no, it's actually the correct answer. I didn't remember that 145 is what we expected there. So if that is the correct answer for the sample, will it be also the correct answer for the input? Is this the correct answer for part 2? And it is. Awesome. Okay, so this was a pretty, I would say it was a pretty straightforward puzzle. And look at that, the lava island in all its glory, it seems. Although we still have a couple of things to do here, so I guess we're going to still have more things revealed. This was the largest mountain in the, oh, and then it seems like we will be like inside the mountain or something for day 16. That's awesome. So okay, let's do some code review. First of all, let's stage all these changes. Actually, I also need to, if we run now check all, we're gonna have a failure because on this day we are expecting these answers. So let's just copy and paste this, paste this into the answers file. And now the check should pass. Okay, and let's review the code a little bit. So this is the hash sum for part 1. That's all good. No need to change that, I think. Part 2 has this questionable parsing inside the main, like, initialization sequence run, which is like, yeah, could be, I mean, probably could be improved. But this is something that I learned about, or have been learning about, dealing with results in Rust. It's like, since iterators are lazy, so when you do split by this returns an iterator, but it's actually not doing any work, any splitting, until you consume that iterator. So if you then chain this with like map parse step, you're still not going to, the parse step is not going to be run there when you do the map. It's going to be run when you consume the iterator. So when you do something like sum, which is an iterator consumer, or when you do something like this, for loop, that is also a way to consume an iterator. So that is when the parsing will, if I had written this as map parse step, this thing would work, for example, but the step here would be a result. So I will still need to deal with that result. For example, doing this ugly thing here, putting the question mark there, or I don't think that there is no syntax for that. And if I wanted to keep, like imagine that if I wanted to extract all of this into a function that says, I don't know, run initialization sequence, and I just want to pass, like what do I pass to that function? If I wanted to pass like the steps already parsed, then I would need to collect them into a vector already. Which, I mean, it's not a bad idea, I think, but I don't think that it needs to be separated, because like we still need the boxes to compute the total focusing power. So I think what we have here is fine. This is just fine up to there. Okay. We got a bit of repetition here, trimming the end, but no problem with that. This I definitely want to change. I really dislike this kind of destructuring in many lines. So let's actually change these things to. It's gonna be a bit ugly that they don't have names, but I think I prefer them to just be tuples. You know, no need to. I wonder if there is there a refactor that can be applied here? Let's see. Oh, extract from enum. Interesting. And this did all the work. That's a very interesting refactor. I didn't know that Rust Analyzer could do that. But well, it's not something that I want to do in this case. From enum variants. Oh, convert to tuple struct. That is exactly what I wanted to do. So that converted the remove here. That's great. And we can also convert the put. And look at that, it did all the work for me. That's that's perfect. That is the kind of thing that I really like about language support. Okay, so when we want to remove a given label, we access the box for that label and retain all the lenses whose label is different. Perfect. This is totally fine. Here we are extracting this. You know what? I sort of want to try just simply doing this instead of like inline this messy thing. I think that would work. Yeah. Yeah, it's maybe a bit noisy, this thing. So this is a itermute. What this returns. Sure. So we can maybe put this into a variable. So call it length. Just, you know, if it is some length, yeah. Change its focal length. And I guess here, yeah, existing lengths, we can say. Yeah, this is fine. Okay, that is fine. The parsing is quite fine, to be honest. Hash is perfect. And the only questionable thing for me would be this. I'm wondering, like, this is just my wondering here. It's like, yeah, Rust iterators are great, like they are super powerful and lets us like do this kind of thing. But I'm wondering if this would actually be more readable if we just had like two for loops, you know? So let's try it out. Let's say, hey, let blah be 0, total focusing power. Have this, and then let's do something sort of like this. We're gonna have let lenses and box index in this. You don't. No, let's not. For lenses and box index in this thing. And then for the lens, which is going to be, well, an unused label and focal length, and the lens index in lenses, itersip with, so the same thing as in here. So for that, we're gonna just simply do total focusing power plus equals this. And that's it. So let's actually run this. Yeah, still the same answers. And I don't know about you, but this to me feels much simpler than this. It's like, okay, you can, you know, I guess you could extract things a bit better here, but this is the same. If I wanted to extract this into like a function, it's the same as extracting this inner for loop into a function. So I think this is much better. Yeah. Okay. So goodbye iterators and hello nested for loops. Okay, and I think that will be it for today's or yesterday's puzzle. Just 50 lines of code to solve this, and it wasn't too complicated, I think. So let's commit this. Add day 15 solution. Okay, and before we go, let's, as usual, create a little thumbnail for today's video. So what was today's puzzle about? It's not about Rolling Stones. That was a good one. It's about focusing lenses, I guess, and running an initialization sequence. And we have a focus power. Yeah, focusing power is what I would need generally in my life to deal with ADHD. I have taken some drugs for that before, but they weren't very useful. I'm drug free now, except for mate, of course. That's my focusing power drug. Yeah. I want to say something about that, like like harnessing focusing power, my focus. This got a bit personal. Let's say Something about focus power is what I'm in search of focusing power. Yes, that describes sort of my state in life currently, and for the last couple of years, I would say. So that's a nice personal thumbnail, I guess. Look at this. It's pretty nice. Pretty nice, neat code, I would say. Okay, I think that is all for today's puzzle, or yesterday's, I should say. Still need to do day 16, but that will be for another video. And as usual, if you have been, thanks for watching and see you later. Goodbye.